Good afternoon. Today we'll be checking out linear equations. Today we have 3 learning goals. Learn how to isolate the variable, verify our answers to see if our answer is correct, learn a bit about special cases in linear equations. So, to isolate the variable, let's say here we have an equation, a very simple equation. 2x equals 3. So, our objective in an equation here, our objective to find the solution, we have to find x. So we have to find out what number x is to make this statement true. What number has x to be to make this statement true? And to find out this, to solve our equation, we have to isolate the variable. Make on this side there be only x, and on the other side a number. So how do we do that? Well, we have to know that the opposite of plus is minus, and the opposite of multiplication is division, and this also works vice versa. So the opposite of subtraction is adding, and opposite of division is multiplying. So in this case, we are multiplying x by 2 to get the answer 3. Well, since this is equal to this, if I multiply both sides by 2, let's say for example I want to multiply both sides by 2 times 2 times 2, here I will get 4x equals 6. Is this does this continue to be true? Well, yes, they're still equal. So what you have to understand here is that if you do something on both sides of the equation, on both sides of the equal sign, the statement will still be true. If I have here 3 equals 3, this is true, correct? This is a true statement. And I multiply both sides by 2, well, 6 equals 6. This is still true. So when solving any equation, actually, what we have to do is isolate the variable by using these rules. So if I have here 2x equals 3, to get x alone, I want to get rid of this 2. Well, if I divide 2x by 2, I will get only x, correct? Yes, I will divide 2x by 2, I get only x. So now the x it's isolated. So x equals 3. Well, actually, no, this is incorrect. I can't just divide one side by 2. I have to divide both sides by 2. So I divided 2x by 2, so I have to divide 3 by 2. Okay, so my final answer for this equation is x equals 3 over 2. And then you say, well, who said? Is this actually real? Well, then you can verify your answer. And that is our second learning goal for today. How do you verify if x is actually 3 over 2? Well, to do this, you have to take your initial equation, so 2x equals 3, and you plug in your solution into x, because since x equals 3 over 2, so if I plug in 3 over 2 inside x, so this will be 3 over 2. Okay, so I substituted x by 3 over 2, since x equals 3 over 2, equals 3. So now, 2 times 3 is 6, so 6 over 2 equals 3. Simplifying this, 6 over 2 is 3, so 3 equals 3. So that is how you check your answer Now I'll be checking out some special cases. So special cases are when we have no solutions and when we have infinite solutions for our equation. So let's check out some examples. So let's say we have here 8 plus 4x divided by 2 equals 2 times 2 plus x. Okay, so when we simplify this, so 8 divided by 2 is 4, 4x divided by 2 is 2x, and then equals, so 2 times 2 is 4, 2 times x equals 2x, so plus 2x. So here we can see that both sides are equal. 4 plus 2x equals 4 plus 2x. So let's say I plug in 2 in x, so 4 plus 2 times 2 is 8, 2 times 2 is 4, so that will be 8. 4 plus 2 times 2 is 8, so that's true. So that's a correct answer. X can be 2. If x is 2, our solution, the statement is true, so that's correct. Let's say I plug in 3. 2 times 3 is 6. 6 plus 4 is 10, so 10. Same thing on the other side, equals 10. So you see here that since we have this exact same thing on both sides, whatever value I plug in for x, the solution, it's true, it's a correct answer. Thus, I have infinite solutions for this equation. Now, let's check out the second case of a special case. So let's see here. I have here 6x, 6 times, let's say 6 times x minus 3 in parentheses equals 3, 6 plus 2x. So I distribute this, so 6x minus 18 equals 18 plus 6x. Okay, so are these the same? Well, no, because in this case, the 6x is the same, but here is minus 18 and here is plus 18. So let's say I want to solve this. I'm going to isolate the variable. So to isolate the variable, I have to pass all values that have a variable inside it to one side and the ones that don't to the other side. So I'm going to subtract 6x to each side, minus 6x minus 6x, so then I can cross these out, and then, well, 6x minus 6x, I crossed these out too. Well, negative 18 equals 18. Well, that's not true, that's false. If I plug in 2, let's say if I plug in 2, 6 times 2 is 12. 12 minus 18 is negative 6. 12 plus 18, well, that's plus 30. Negative 6 is not equal to 130. If I plug in 4, say 4 times 6 is 24. 24 minus 8 is positive, minus 18 is positive 6. 24 plus 18, well, that's 42. Well, that's not true either. This is a special case. There is no possible solution. So now let's go to some examples to see if you guys understood everything well. In our first example, we will be solving 3x over 4 minus 12x plus 16 over 5 equals 3x over 2 minus 15 over 4 plus 7x. So let's keep the x's to the left. So 3x over 4, that has a variable, minus 12x also has a variable. So now let's subtract 3x over 2 to both sides, so then we can get rid of this 3x. So minus 3x over 2, and then I'm going to subtract 3x over 2 on this side as well. So then I can cross these out, so 3x over 2 minus 3x over 2 is 0. Okay, and then I still have a 7x here. So I'm going to subtract 7x to both sides, minus 7x, and then I can cross these out too. 7x minus 7x is 0. So I still have on this side that I didn't add to my rewrite of this equation is positive 16 over 5 and this negative 15 over 4. This negative 15 over 4 is already to the right, which is where we want to keep our numbers without variables. So negative 15 over 4. And then this positive 16 over 5, I want to subtract 16 over 5 to both sides. I can cross these out. And then minus 16 over 5. And then now I have to solve this equation. Well, how do I do this if I have these denominators here? Well, what I can do here is to find a common factor. So that when they're all in the same factor, I can just multiply both sides by that factor and get rid of all the denominators. So let's see here. I have 4, 2, 4, and 5. Well, that will be a 20. So 3x over 4. So that will give me 15x over 20 minus 24x over 20 minus 30x over 20 plus 140x over 20 equals 64 over 20 minus 75 over 20. So now, well, if I multiply both sides by 20, I can cross all these out. Okay, cross, 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 cross. So now I have no more denominators. So now I have 15x minus 240x minus 30x plus 140x equals 64, negative 64 minus 75. So that will get me, I'll calculate this, 15 minus 240 minus 30 plus 140 will get me negative 395 equals negative 64 minus 75 will get me negative 139. Well, I'm sorry, I forgot an x here. Negative 395x. Well, I don't really like these negatives, so I'm going to just multiply both sides by negative 1. Multiplied by negative 1, multiplied by negative 1. So negative 1 times negative 395x is just 395x. Same thing on the other side, so that's just 139. And now I have to isolate the variable. As we did there in the very simple example of 2x equals 3, I'm just going to divide both sides by 395. And then I can cross these out. So x equals 139 over 395. X equals 139 over 395. And that is our final answer. Now let's go to our second example. So here we have 5x divided by 2 minus 8 times 3x plus 1/2 times 3 over 2 plus 2x minus 2x equals 3 times 4x over 9 plus 3x minus 2 plus 2x over 3. Jesus, that's very long. So how do we do this? Well, first of all, let's just do these multiplications here, these simple multiplications. So here I already did some for you. Multiplied 8 by 3x, so 24x. And 1/2 I multiplied by 3 over 2, that gives me 3 over 4. And 1/2 times 2x gives me just x. And then, okay, I minus 2x here equals, so 3 times 4x over 9 will give me, so that's 12x over 9, which I can simplify, 4 over 3x plus 3x minus 2 plus 2x over 3. And now get rid of these denominators. So here I only have your 2, 4, 3, 3. So this common factor here will be 12. So to get to 12, that will give me 30x over 12 minus 24 times 12. So it will give me 288x over 12 plus 9 over 12 plus 12x over 12 equals 16x over 12 plus 36x over 12 minus 24 over 12 minus 8x over 12. And then to keep this balanced, I'm going to multiply both sides by 12. Okay, multiply both sides by 12. Then I can cross these all out. So now I have 30x minus 288x plus 9 plus 12x equals 16x plus 36x minus 24 minus 8x. So now I have to get all the values with variables to one side and all the values without variables to the other side. So I have to get this 9 to this side and all these x's to this side. So I will get 30x minus 288x plus 12x minus 16x. So what I'm doing here is I'm just in my head, I know that this is 16x, so I pass it to the other side with the different sign. What I'm doing is essentially just subtracting negative 16x by both sides, but to do it much faster, you can just think of it, okay, I'm just going to pass it to the other side and change the symbol. So same thing, negative 36x plus 8x equals negative 24, and then there's this 9 here, so this 9 I can pass as negative 9. That will get me negative 330x. Okay, so, and on this side I will get negative 33. So negative 330x equals negative 33. So I multiply both sides by negative 1 to get rid of the negative. So negative 330x equals 33. Divide both sides by 330. So x equals 33 over 330. Then I can simplify this. So divide this all by 33. So this will get me x equals 1 over 10. And that is my final answer.